So we're going to go all the way down to the graph. This is, by the way, is preparing us for your next worksheet. So the first thing I want to do is find the x-intercepts. The x-intercepts I find, those, by the way, are also the zeros, roots, solutions. Set that equal to 0. So this would tell me that x is what? -1, and x is? -4. And what's the multiplicity on -1? 3. What's the multiplicity on -4? 1. Because here, this guy is 1. Y-intercept is where x equals 0. So it's going to be -1/2 times 0 plus 1 cubed times 0 plus 4, which is -1/2 times 1 cubed times 4, which is -1/2 times 4, or it's -2. So it's going to be x equals 0, y equals -2. So here's my table. The zeros are -1 and -4. The multiplicity on -1 is 3. Does the graph touch or cross? Cross, because it's odd multiplicity. And a multiplicity of 3, what's the shape I would expect to see? An S-curve. Why? Because he looks like x cubed. Multiplicity 1 is what -4 is. Does it touch or cross? Odd multiplicity crosses. And what does it look like since it's multiplicity 1? A straight line. Because degree 1 is a line. Degree 2 is a parabola. Degree 3 is an S. What's the power function? Well, it is -1/2 times, highest power coming out of x plus 1, the quantity cubed, would be x to the third. Highest power coming out of x plus 4 to the 1 is x. This guy is -1/2 x to the 4th. That makes him an even degree polynomial. So he's even degree. Leading coefficient is -1/2, which is negative. That makes his end behavior what? Even. Even does not begin with O. Even begins with E.
Bottom, bottom.
So it's got to be bottom, bottom, or top, top. So it's going to be the same. So it's going to be bottom, bottom. That means it's this. It's going to come in from the bottom, out to the bottom. The only time you have letters that aren't the same is when you've got odd. What's the maximum number of turning points? I know we forgot this from yesterday. It's the degree minus 1, yeah. Which is 4 minus 1, which is 3. That's the maximum number of turning points. That's the number of humps, hills, or valleys. And you're going to say, yeah, you're going to do a graph with just that? Yeah. Now, I don't know what the y values are. I don't know how high they go. I don't know how low they go, but I know they go. So the first thing I do is I put on my graph paper the x-intercepts. The x-intercepts are at -1 and -4, and I know I've got a y-intercept at -2. Now, what else do I know? I know that at -4, the graph crosses. -4, the graph crosses and looks like a line. So on -4, I'm just going to put a little L that tells me that's going to be a line. At -1, the graph crosses and it looks like an S. So at -1, I'm going to put a little S. Now I know it comes from the bottom and goes out through the bottom. Now, when I was a little kid, one of the things I used to have, and some of you girls will probably more than the guys, but even then, if you were thinking about repairing something that has holes in it and you needed to put a piece of string through the holes, you would feed the string through the hole and you'd follow the holes around. What you want to think about is these guys being holes and I'm feeding a string through. And the shape that that string's going to make, I've now marked. That says I'm going to bring my string up from the bottom and I'm going to go through that guy like a line. Now that string has to do something. In other words, it's going to come up and what goes up must come down because he's got to come down to this and go through this guy. So I'm feeding that string back through. So it means he comes up. I don't know how high he goes, but I just know he goes high. And he comes down, and I know he's going to be some kind of an S-curve. So I do my best to make an S, and it's going to be kind of a reverse S, and feed it through. That's what that guy looks like. I don't know how high, but those are the shape. That's the shape that he would make if I were to graph him. So if I put in my grapher, and I'm just going to do a zoom standard because I'm only interested in the x-intercepts. So negative, I'm going to use 0.5 for 1/2 times x plus 1 to the third times x plus 4, and I'm going to just do a zoom standard or zoom 6, and there he is. It's very similar to what I've drawn, right? And that's essentially what you're doing. You're getting a pretty good look at what this thing's going to look like without having to do a lot of coordinate points. And the x-intercepts, by the way, is what's in control of it. That's what's in control. The x-intercepts. So we're getting a kind of a seat-of-the-pants look at what it looks like without having to do a lot of coordinate points. Now, by the way, the fact that the graph appears on my graph paper running minus 10, 10, minus 10, 10, is a negative 1/2, and 1/2 is a vertical shrink. So it's actually shrunk the graph down this way, which is why you can see the turning point or the hump. Chances are very good on a lot of these guys you're not going to see it. That's why I'm only interested in what this thing does at the x-axis, at least for the time being. Cool, huh?